right, I'm still getting organized here. Welcome everyone. Made some changes here. Tried to kind of improve the quality. It looks like the video wasn't that great. Video quality wasn't that great, so I think I bumped it up. Should be better quality now, hopefully. All right, let me find my notes. I apologize. We're trying to ship a feature to a customer today. So things have been a little hectic this morning. So welcome everyone to Fleet Office Hours. Trying to pull up my thing. Okay, there we go. Thanks for tuning in and bearing with me. You know, this is all live, not really scripted, pretty raw stuff. So, which is good or bad, right? So my goal here is to answer technical questions, to give an opportunity to anyone interested in Fleet, curious about Fleet, customers, developers, even, you know, anyone else that works at a Fleet could jump in, right? Ask questions about Fleet, codebase, the company, anything you'd like. You know, I may not have all the answers, but I'll try my best. I'll try to reason through it and try to figure out the next steps. So, you know, lately I've been trying to kind of put a theme around these live office hours, as opposed to just, you know, random stuff, to give like a heads up. So today's theme is vulnerabilities and IdP. I thought I was going to talk a little bit about different vulnerabilities. I thought I was going to talk more about like supply chain vulnerabilities, but I'm actually just going to talk about like our feature. And once again, not prepared. So I have a rough idea where I want to go, and I do want to kind of dive into some code for vulnerabilities. All right, so with that, this is our Fleet instance. So what are we talking about here? Vulnerabilities, roughly, right? You go to software, and then we track these vulnerabilities. Let's do this one, right? We have two vulnerabilities. I click over here. I see the vulnerability here. So that brings me to the version of this host, right? So just backing up again. So we've got this page. So has software. It combines all the versions. So see down here, you have different versions. Some of this data is artificial. That's why, you know, a lot of Python versions, man. We can also, and there's like 100,000 items here in my database. This is a local database, so artificial host, artificial data. I can also click show versions. And now each version is going to have its own row. So in this case, if I click on this, I expect, yeah, it'll just go back to this page. And then I can click on this. This will take me to a vulnerabilities page. It's going to give a little blurb here about the vulnerability. And we can also go to NVD page. I'm not going to like dive into these details. I'm just going to kind of talk about the process. Okay, so how do we get all this data in here? Let's dive it in. High level, you're on a job that looks at NVD, looks at other feeds, looks at Microsoft, cross-references it to all the software we have installed. You know, there's some rules, some special cases that are handled, and then populates this process. Lately,
I think we need to kind of optimize this, because as we're scaling, as we've got customers who have more hosts means more software, hundreds of thousands of different versions or different software titles. Titles is like the like Grammarly, right? That's a software title. Versions is there's 125 versions of Grammarly, deployed across my fleet. All right, so let's just, I haven't actually looked at this code in a while, so this is going to be kind of an exploratory exercise. Hopefully it'll be interesting just to show how I figure stuff out. But let's dive into it. So I know we have vulnerabilities job. I also know that our vulnerabilities job has some issues. So let's actually, just to make sure, let's make sure we copy, duplicate. Okay, let's take a look at specific issues that we want to solve with vulnerabilities page. So we have some bugs. Let me search for vuln. We have some positives. We have some cleanup job. Vulnerabilities count increase over time. I don't think it's relevant. Let's take a quick look. Things get slower. Orphan vulnerabilities. Okay, orphan vulnerabilities are not being cleaned up. I see. I think, yeah. Okay. So this is not annoying issue, but not like critical, right? So I think what's happening here is, we've got these vulnerabilities we have in our database, but then our customers update their software, right? So there's 24 versions. A month later, customers are going to update. These versions are going to be different. And some versions will basically go away and will never be installed again, right? Because they're old. But it appears to be that we're still keeping around the vulnerabilities associated with those old versions. Yeah, so yeah, looks like it's, we have multiple sources of vulnerabilities, so it looks like it's specific to some vulnerability sources, not all of them. Okay, good to know, not something critical. Let's see, anything else? We got specific vulnerabilities here, specific vulnerabilities. This is the one I'm interested in. Let's come back to that one. Red Hat Alma Linux, Red Hat kernels, okay. Inventory inlined. Not sure what this is about. This is a story. I see. This is like our internal code base vulnerabilities, like libraries we were using. So this is not software vulnerabilities. Yeah, I know vulnerability is a broad term, so it can apply to not only software items, but to like libraries that we use in our code. Ignore all this. Let me close close all tabs. Let's go on main. Latest main. Oh, all the tabs. Close all tabs. So like go.mod. We're using like JavaScript, we're using Go, we're now using Kotlin for our Android app, we use C++ for our query, so we use multiple languages. So here, for example, we're using all these dependencies. Maybe the AWS SDK has a vulnerability, right? That's also a vulnerability, but it's like a vulnerability with the fleet software effectively, right? If we're using a library that's vulnerable, then we need to review and decide whether we need to upgrade, fix that vulnerability, or whether it's like, or waive it. Anyway, slight tangent. So I was looking at our issues related to vulnerabilities.
Windows perversions, yeah, we have some issues with Windows, foreign language versions and stuff like that. Okay, cannot trigger vulnerabilities job. Okay, this is another interesting one. Briefly mention this one. All right, so vulnerabilities job takes a lot of resources, right? It, like I said, it goes through all the software, updates all the software. It fetches a lot of data from external sources. It processes a lot of data on the database, and as such, it consumes a lot of CPU. So oftentimes in like larger deployments, we would put we would spin up effectively a separate server, and that server is the only one that's allowed to run this vulnerabilities job. But then what happens is that server is like effectively on its own. It's kind of cut off from the normal servers that respond to API requests. And so this means when we run a command from fleet CLI, like fleet control trigger, that's not going to go to the server that has the vulnerabilities capability. It's going to just go to a general server, and that general server has the vulnerabilities job disabled. So it can't start the vulnerabilities job because it's not allowed to run it because it's run on another server. So that's kind of creates a testing. That kind of creates an issue because definitely during like testing, because sometimes you just want to trigger the vulnerabilities job. Maybe something changed, or it's the first. Oftentimes it's like the first deployment. Like I bring up fleet, like I'm working on bug related to vulnerabilities. So the first thing I want to do is run the vulnerabilities job. Yeah. So that would be a good fix for developers. Also for customers, right? Because customers do use this process, this way of running fleet as well. One server for vulnerabilities, one server for everything else. All right, so performance issues. As we're scaling, we're starting to get more and more performance issues. So this is just another big one that we need to handle in the next couple of months. Where is it? Here we go. Linux vulnerability processing. I think the reason it has Linux in the name is because we added like Linux kernel vulnerabilities that we didn't have before. Let me demonstrate. We click on OS tab. Yes, OS tab also has vulnerabilities. And as you can see here, these Ubuntu versions have a lot of vulnerabilities listed. Well, the reason they have a lot of vulnerabilities listed is because each Ubuntu version can support multiple Linux kernel versions. Let's see what happens if I click on it. Yeah. So for example, in our fleet, this Ubuntu version, and this may be made up. There may not be a real version like this, but this is just, some of this is artificial data. This Ubuntu version has, in our fleet, has all these Linux kernel versions. Some of these are fake as well, but this is just for demonstration purposes. And each one of those can have vulnerability, so it's like an exponential problem here. Yeah, and the numbers don't necessarily need to add up, right? Because between these vulnerabilities and these vulnerabilities, there's probably a bunch that are the same. So if we just take all the unique vulnerabilities out of these, we end up with the number on the previous page, right? Whatever it was, this number. Okay. So that's probably why this was opened, right? Because once we added that, gathering all these kernel vulnerabilities, like the runtime shot up. 8 hours. It's actually, the first run, you spin up Fleet, you enroll a bunch of hosts. Normally we, in a load test, we enroll about, 10,000 or more, 50,000, 100,000 hosts. Not real hosts, but they have some artificial software, some kind of real software. And so we spin up Fleet, we enroll all these hosts, and then the vulnerability job runs to figure out all the vulnerabilities across all the software and all those hosts. And yeah, the first run takes a long time. Like maybe this is expected to a certain degree, but I mean, this is a really long time, like 8 hours here, right? This is like, from a development perspective, that's very inconvenient, right? I'm working on a bug. Before I verify the fix to that bug, I need to run the vulnerabilities job. You go and run it, and then you wait until the next day, right? That's not... Then the bug doesn't fix. Maybe you have to restart everything over, right? Slow development process, not great. All right, let's dive into the code. Vulnerabilities job. Should I talk to AI a little bit? While we're looking at the code, let's give it an answer. Explain how the vulnerabilities job works. Specifically, what are the major parts of it? Yeah. While that's going, let's find it. Vulnerabilities.go. It would be, I'm not sure if it's going to be here. List vulnerabilities, okay. Count vulnerabilities, okay. So I really want it to be, it's a cron, right? Vulnerabilities is here. Here we go. Here's where the starting point is. Let's go up again. So serve.go. So this is like the thing that runs when you start the Fleet server. So Fleet server starts, and this is that, I think this is what I'm talking about, that switch that you can disable the job on certain servers using this config vulnerabilities disable schedule. Yep. So if it's not disabled, we effectively schedule it, right? And I think it runs every hour. Periodically, where's the hour here? Name, periodically, interval, where's the interval? Period, config periodicity, okay, it's configurable, but it defaults to an hour. One important thing to note is it doesn't mean it runs every hour. It means after the last one finished, it'll take an hour before the next one starts. So sometimes we don't quite correctly say that that vulnerabilities run every hour. They run with an interval of 1 hour between the runs. I know, that's probably a better way to say it. But that's something that, once you like dive into how it really works, you see that, okay, it's not actually every hour. Okay, let's see what our AI Cloud Code told us. Yep, it's a cron task. Entry point is cron. This is where we're at. Alternative CLI allows running externally via vuln processing command. This is interesting. Is this for testing? We have vuln process command. So we actually have another executable. Does this have main? What is this? main.go. I see. Okay. Yeah. Okay. So I was a little bit wrong. That serve, when you write fleet, you give fleet a command. One of the commands is serve. So let me show. So I've got fleet server running. I've got a fleet server running. Let me hide my screen for a second. Because I thought I put in some variables. I'm not sure. Okay, that's cool. I'll share my screen. This is like I've got like a wrapper. So I run build fleet serve. Build fleet serve, right? That's how I start up the server. But fleet has additional commands. And one of those is looks like the vuln processing command. So what does that mean? That means I'm not sure what that means. Like you're not running the server, but you're running vulnerability processing. Let me read this. Run vulnerability processing features of fleet. Advanced configuration, externally manage vulnerability processing, externally manage. So it's like on demand. I see. So it's like, yeah. I'll have to talk to the infrastructure guys. It feels like the intention here is you got your normal fleet servers. And then on your own schedule, you spin up a new server and you just run fleet vuln processing, right? And it should just runs the migrations. Okay, that's cool. I mean, I wonder if this is actually being used. Like, it's here. It makes sense. Feature makes sense. Let me vuln process command. Where's the actual command? Return vuln process command. I'm not. Is this it? Is this the run? Okay, we run here. Okay, we run migrations. What is this? Lock. Okay, lock our cron. Okay, that's fine. Configure vuln path. Get vuln functions. Vuln functions. Okay. Let's make sure this is the same as the cron. So it looks like this is the key here. Get vuln functions, which is okay, which is all these. Let's go to cron. Let's see what this does. It just does the same thing. Okay. Get vuln functions. So what are these vuln functions? It feels like we should have, this is the same, it's the same, it's vuln process. Both of them go to the same place, right? I'm not crazy. We got the cron. We schedule each one of them. I see. But the whole thing, schedule new, we append the functions. What is this exactly? Adds a job to the schedule. Okay, but each job, when it runs, each job runs. Each job has a name. Okay. And this is the name. Okay, so one of the ways that we need to solve this problem is to add some telemetry. Let's see if I have my telemetry thing running. Docker. Let me see. Where's my Docker? Docker desktop. Go to dashboard. Yep. Okay. Yeah, I really want to be using Hotel more. So part of the way we figure out what's wrong here is we measure how long things take, right? So I assume cron vulnerability is the one that takes a long time. Let's go back to the bug. Cron vulnerabilities, right? This is a little bit confusing. Cron vulnerabilities. This is called cron vulnerabilities, but cron underscore vulnerabilities. And this is called cron vulnerabilities, which is just vulnerabilities. So how this works is a cron is our fleets cron, not like Linux cron. Fleets cron has multiple jobs. Okay, so inside of this job, it runs these vulnerability functions. So the first thing I'd want to know is how long each of these takes, right? So it looks like the whole thing, running all of these, takes 8 hours. But do they all take like 2 hours? Or is this one up here taking like 8.5 hours and the rest of them take like a couple of minutes? Yep, right? Makes sense? So the first thing I'd want to do is I wanted to check in our telemetry whether these show up. I think they should show up as separate spans in telemetry because I believe I added telemetry for jobs themselves, but maybe not. This is the first thing to check. Like, are we seeing this, a span with this in the name in the telemetry, right? All right, let's dive in. So we kick off our job, and each of these jobs calls this vuln function, right? Because with job options, what does options have? Options have jobs, some metadata. Okay. So basically, naming is a little confusing here, I think. It's called option. Maybe not. Maybe the fact that it's called schedule option. I think this is where I'm being confused. The type is called schedule. The package is also called schedule. So the naming is not great here. Schedule package contains schedule type. Yeah, I feel there should be a squiggly line here saying, hey, you called your type the same thing as a package. I think it's a bad practice just because of this confusion. Because now I look at this and I'm like, an option for what exactly? I guess an option for schedule, but this schedule package can have a whole bunch of stuff in it. Like, what exactly is the option for? Like yeah, this would be better, schedule option, but then schedule option also kind of awkward. Something maybe to clean up later. All right, anyway, so it's a slight tangent. So just time check. I think we'll talk about this maybe 10 more minutes. And then we'll switch to talk about IdP. All right, let's get going. let's jump into, come back up to cron vulnerabilities. All right, what do we have here? Configurations. This is sort of a bug, right? It's possible that you disable your software inventory, meaning you don't want to see any software on your fleet instance. So when you go to software, you don't want to gather the software, you don't want to see it in your fleet. If that's the case, this is interesting. Oh, I killed the server, that's why. My bad. Yeah, and if you don't want to see any software, then we disable vulnerabilities. That is a little bit of a problem, and let me try to remember why it's a problem. Because okay, it's a problem because it links software inventory and vulnerabilities, right? You either get both of them or neither of them. That reminds me. Let's double check. What did this guy say? All right, we vuln processing one instance at a time. That's right. There's 6 major vulnerability scanners. Okay, NVD vulnerabilities. OVAL for Linux OS package. GoVal dictionary. I mean, I think GoVal dictionary is also for Linux. Then we have for Mac Office versions. Separate scanner. Custom vulnerabilities, I'm not sure what that's about. And then, oops, wish there was a shortcut. If anyone knows the shortcut to get me to the bottom right away of this terminal. Okay, so NVD scanner, primary for software, right? And this, we're talking about NVD vulnerabilities. We download the CP database, CV feeds, CPSS scores, see some known exploits. So we download a bunch of stuff. Then we map all our software to CPEs, and then we translate CPEs to CVEs. I mean, I feel like this is like where probably most of the work happens. Downloading. Well, let's just keep looking at the big picture here, okay? OS vulnerability scanner. This is, okay, right. We have software vulnerabilities, and then we have OS. Linux specific, Windows specific. What about Mac OS? What about Mac OS, iOS, Apple stuff? I don't know. I'd have to figure it out. OS post-processing. Post-processing, okay, we do some aggregations. We go to trigger webhooks, etc. Yeah, okay, makes sense. Vulnerabilities config. Should we take a look at it? Vulnerabilities config. Config, go. Just want to remember to come back here. Let me close other tabs. Config.go. Line 549. It's already there. Okay. JSON YAML. Okay. Configs. And I imagine this is all documented in our fleet docs. Maybe not all of it, but like the major features that customers are using. So if I go to fleetdm.com, more docs. If I search for this, fleet server configuration, So yeah, so we have all these explained, documented here, periodicity, vulnerabilities. Yeah, we have a good section on these things. So it's you know, it's a decent sized feature, right? You know, we've been working on it for a while. Let's get back to the code. Okay. All right, we're good. Let's circle back and just try to go through this. Cron vulnerabilities, app config, configure vuln path. Configure vuln path, it comes from vulnerability setting database path. Okay. So it'd be nice to actually like in the code know what this is. But we do have this nice documentation, right? We know it comes from here. Databases path. Okay, to and fro. This is the only mandatory configuration. Okay. Create database. Yeah, so it's like a temporary directory. Yeah. It's a temporary directory where Fleet is going to download some files, some SQLite databases and such, and is going to put those in this temporary directory. And so this speeds up subsequent runs, so that way those databases don't need to be downloaded again. Let me give you an example. For example, today is 2025. All right. You know, software is still vulnerable to vulnerabilities discovered in like 2022, right? So there's a database of 2022 vulnerabilities, right, that we download once, and that almost never changes, right? Yeah, there may be some update to our 2022 vulnerability, but largely it doesn't change. So the first time vulnerabilities runs, it's going to download all these databases. I can actually see what's in mine, right? Let's go. Let's go cd temp fold. Yep. So here's what it looks like. Oh, CVEs. Yep. So basically, we're downloading CVEs from all these years. Interesting that you notice these files keep getting larger. Every year, there's more CVEs. So we're like 5 times more CVEs than we had 10 years ago, right? In 2024, 5 times more. 2025 is still going, but it still hasn't caught up to 2024. Interesting. So maybe 2025 is not that bad as far as CVEs are concerned. No, I mean it's bad, but maybe not worse than 2024. What else do we have here? We got our SQLite database. This is where we map our software to CPEs. So basically, things that we need for vulnerabilities processing, we put in this directory. I mean, I think the name is a little. Databases implies everything's a database. Like this is a JSON file. Is that really a database? Anyway, that's what we have. One more minute, then we'll talk about IdP. Let's see. Scan vulnerabilities, update vulnerabilities, host count. This update is just a single data store method. but it's got a bunch of stuff going on here. Okay. Global count, team count. It's got routines. It runs routines. That's interesting. Interesting. What? I wonder if this used to be an issue, because I feel like doing this simultaneously is going to cause issues. What do we set max routines for? Max concurrency, config, vulnerability config. Back to our docs. Wow, it's not here. So like I was saying, most of this is documented, but sometimes it's more of a development switch. So at some point we thought that we can speed this up. Speed this update up. Max concurrency, let me find it. Okay, let's just find where the default is. So normally I do find usages. I go here now. This is where it's used. This is get config int. Let me search for this. Yeah. So I thought, okay, this is just double checking. So we decided that it would be faster if we run this thing in parallel. But after some testing, it was having a lot of database load. So we backed off, which means we have all this code. You know, we put in all this code to run things in parallel, which we're not actually using because we're setting concurrency to 1, which means run one thing at a time. All right. We talked about vulnerabilities. Like, if anyone's interested to continue talking, I can certainly do that. Just make sure to kind of post it on LinkedIn or in the chat. But let's talk about IdP next. Let me put an X to next to vulnerabilities. Okay. All right. So let's talk about IdP. Right. So, I want to talk about specifically IdP variables. So IdP, identity provider, like Okta, Microsoft, Google, other smaller providers, right? You have your identity provider, and then when you enroll your device, you like log in with your username and password from your identity provider, and that information gets stored, right, in Fleet. So for example, this might be blurred, but I think let me see, do I have, so I've got my Mac Mini, right, and yeah, so like this. I didn't log in with IdP, but if you did, all this stuff will be populated, right? You'd see a username, department, full name. What was that about? Oh, okay, let me log this. So I can add a user here. This is a recent feature, so you can actually, if for some reason it wasn't synced up, or this flow was broken, or you just want to let people enroll, you can manually assign a user to a host.
So this shows up. They still don't because this information comes from IdP. Let's actually go there. Settings, it tells you where to go. Settings, integrations, IdP page. So we go to settings here, integrations, IdP. Interesting. And here we just, not great. We tell people to go here, but from here we tell them to go here. We go, specifically we go here, verify connection. Okay, I see. But this is how you configure. We have instructions for Okta. We got instructions for Entra. And then what do we say for Google Workspace? And the way we sync is using the SCIM standard. It's a standard where Fleet acts as a server, and then the IdP, like Entra and Okta, send users and groups to Fleet server. So then once a person logs in to Fleet, we can cross-reference that data with what SCIM provided. And the IT admins who configure SCIM decide what data Fleet gets. Fleet doesn't need all data. In fact, we don't. I think we just gather the basics: username, department, groups, things like that. Basically, this is the things that you see on the host page. Yeah, groups, department, full name. Just a note, currently we're largely assuming that the username is your email. We do need to kind of fix that at some point, but from what we've seen, our customers are largely, maybe, I don't want to say all of them, but I think vast majority of them have it configured that the email is the same as the username in their IdP. Now, back in the day, you'd have like a Linux username or a Windows username wouldn't be your email. But I think nowadays everyone's like just using email as the username. Just like one less thing to remember, right? Okay. So these IdP variables, they can be added to profiles and to a feature that we're working on, Android certificates that I've been working on recently. The whole team's been working on it. We can put like a variable for an IdP username or IdP group, maybe not group, department, and that'll be automatically populated by Fleet to your macOS profile or your certificate. So let's search for what exactly we support. Maybe I'll look in the code first. Let's do a search in our docs. So let's search for IdP_username. Let's see. What if I put this in quotes? Is that gonna help? Yes, it does help. Here we go. IdP username, okay. What is this page? Platform SSO with Okta device access. Okay. I don't think this is the one I'm looking for exactly. Fleet var. This is an example of a variable. Fleet var host and user IdP. Okay. Let me see if there's a different page. I'm looking for a page that like lists all of these. Oh, this is nice. It automatically pasted this thing.
Connect users. Okay, here we go. Somewhere here we should have a list of these fleet variables. Look at that, I wrote this article. Okay, Apple's built-in variables, okay. Small step, scap. Sorry, it's just strange. I thought we had a list of them somewhere. Maybe it's just not. Maybe it's like in contributor documentation. It's not up on the website, but it's in the code base. Let me search for this in the code. So I want to search for host and user. Let's search for that. Yep. Okay. We got them listed in the code. Okay. Username. Username local part. Confusing, right? I think it's like if your username is abc at example, local part is abc. Groups, this will be multiple groups, right? Department full name. Okay. So that's what we support. So how do we, let me see. So a couple things we can look at, right? We could look at code that replaces them. So let's find where this local part is used. Let's just look at some code. Find usages, tests, trigger recent profiles. Okay, and skim. Yeah, makes sense, right? This is important. Let me just, before coming back to skim.go, let me see where else it's used. MDM, looks like we got a regular expression here. Okay, we got a regular expression so that we can like extract this guy. Oh, look at this. This is kind of clever. $$1. I like this, right? I think this. I mean, I think I originally created some of these, but someone's improved it, which is great. Let me call out who improved this. Well, I can do that by annotate with git blame. Magnus improved this. I assume he made this change. Anyway, I'm not gonna. Thanks, Magnus. Anyway, I think that how this works is this %s is basically duplicated here. Some clever regex. Just nerding out on this. All right, so where were we? We're doing a search. Okay, profile variables, process profile contents. Okay, this makes sense. Okay, so let's go to skim. Which is like an important feature here. Trigger resend profiles for IdP user added to host. Okay, so what we just did here, right, is we went to a host that didn't have a user and I added a user here. So once I add a user here, that means this variable, IdP username, fleet var host and user IdP username, it's now valid, right? Because it now has a value. So it means any profiles that are using that variable are now valid. Before they were not valid. Generally, if you put IdP username in a profile and IdP username is blank, we error, right? Because we say, hey, you want to populate something, but it's not there. So we generally throw an error there. But then if you go and somehow that user gets synced to your IdP, it could be multiple ways to do this, right? And we're in the skim.go file, so this is kind of our skim implementation. So here, the user was actually added to skim, and we linked it to an existing host. And so once we do that, we say, hey, we actually need to resend the profiles, right? Let's dive deep into this. Resend profiles. Okay, so we're actually doing some database stuff here. Okay. Apple profiles, Windows profiles. Unfortunately, I do not see declarations. Let me think about declarations. Why would there be one in declarations? I guess we don't support fleet variables and declarations, but at some point we will. So currently Apple profiles, Windows profiles. And what we need to do is we need to add this to certificates now, specifically Android certificates. We got a couple of minutes left, but I want to show exactly where we need to add this. So we can go to controls. This is an upcoming feature. We now have certificates only on Android, and we can add a certificate. And here's an example actually where you can use your username. So this is an upcoming feature, right? So that means if there's a change to the username, someone changed their last name, whatever, Skim pushes out an update. We need to push out a new certificate with the updated username. All right. Thanks for watching, everyone. Thanks for tuning in. It's great. Like and subscribe. Anyway, I'm going to take off. Had a great time. So I think it's like New Year's Eve in 2 weeks. So we're going to do the next live office hours in 3 weeks. All right. Thanks for watching. Yeah. Keller. Hi, Keller. All right, let me read. I have to run a meeting in a minute, but I have a user for whom the MDM says fleet installed successfully, but they don't appear in the hosts. What's the best way to troubleshoot client connections? That's a good one. Unfortunately, I have to run. Let me think about this. Fleet installed successfully. User for whom MDM says fleet installed successfully. They didn't appear in hosts. Okay, they should appear in hosts. All right. I apologize because I have to run, but we do have our Slack channels open. You know, our response is pretty good on Slack channels. All right. Thanks for joining live stream, Keller. See you later.